Hello, it's Keith here, and this is the second in the so-called MinTile series of my Z80 assembly programming tutorials. We're looking at my minimum tile map routine here. So this is a multi-platform one. We've got the Master System one on screen here, but it also runs on basically all of the systems in my Z80, 6502 and 68000 tutorials, and it does the same thing in the same way on all those systems. The idea being, if you need a tile map that works in the same kind of way on a Spectrum and also on an MSX, despite the fact that one is software screen and the other's hardware tile map, well, this will allow you to do it in basically the same way in all systems. So that's what we're going to be looking at, and today we're going to be looking at the draw sprite routine and the cropping routine. Now you can see we've got a character moving across the screen, and it's cropped within 8x8 tile blocks here. I should point out that the version you're looking at here and most of the versions don't use hardware sprites in any way. They simulate a sprite with the tile map. So we don't actually have any sprites, but I use the word sprite to refer to a small moving object that is drawn by changing the tile map entries within the tile map or drawing simulated tiles to the screen. Okay, well, let's go over to our code and let's take a look at what we're going to be seeing today. So we're going to be looking at this draw sprite routine today. You can also see we've got this flag sprite for refresh routine. Now all of these routines use the IX register to point to an object with a variety of variables contained within for various purposes. And so when we want to update a sprite, maybe it's moved or it's been overlapped, we would set the flag for it to be refreshed. And there's two parts. There's one that says to refresh what's under that sprite and one to say refresh the sprite itself. So that's what we've got. Now, when the draw sprite routine is executed, we're checking if that refresh flag is set, and if it's not, we just return without doing anything. But if it is set, then we need to clear it, and then we're going to actually draw our sprite. Okay. So the first thing we're doing here is we're loading the memory address of our tile map here. So we're loading that in, and we are loading our X and Y position into B and C here. Now, on most systems, if we're working in an 8x8 grid, it's going to be more effective to sort of drop the bottom 2 bits of our X and Y coordinates. Now the X and Y coordinates, width and height, are in what I refer to as logical units. Now one logical unit is 2 pixels, one tile is 8 pixels, so 4 logical units. And so to convert from logical units to tiles, we're zeroing the bottom 2 bits here. Now MinTile is very crude and it doesn't work so well with partial tile movements if the background isn't entirely redrawn, and you can get glitches. And so by reducing the resolution of movements with these low res functions, we can resolve those glitches but sacrificing smoother horizontal and vertical movement. So once we've done that, we're then basically updating the old X and Y position. This is for removing the sprites later on, and what we're then doing is we're loading in the pattern address. This is the address of the bitmap data that is used to draw the tiles on bitmap systems. Okay, next what we're doing here is we are checking the flip flag here. We're loading that in. Now if bit 0 is 1, then we're going to X flip the sprite. What we're going to do here is we're going to calculate the cropping. Now we've got this do crop routine which will calculate if our sprite is partially off the screen, because in a case like that we will only need to draw a few of the tiles. So we're going to see that do crop routine in just a moment. It will set the carry if the sprite is entirely off the screen, and we will give up in that case. Now once we've run that, we're going to then convert the logical units that returns into a number of tiles. So we're converting the width and height here into a number of tiles here. So we're just basically dividing them by 4 here. Okay. We're then running get screen pos. This is a platform specific routine which will return HL as the memory address of the top left position of the sprite, which will be using B and C, which will have been altered by the do crop routine potentially depending on the position of the sprite. So if the sprite was in a position like this, then it would be changed to 0, 0. We're using an invisible border around the logical screen basically. The do crop routine is almost identical to the one in the simple series. It's just been tweaked slightly, so it uses the same coordinate system as we did there. Now once we've done all of that, what we're going to do is we are going to basically get the width of our tile map here in IYH. We loaded that in here. So we're just pushing that in HL there and popping it into AF there. And so that's the tile map width. We're then checking whether we want to run draw tile map or draw tile map reversed based on the bit 0 of the flags here. Now we saw the draw tile map routine last time. That is the routine that will draw a small tile map that is basically being used to simulate a sprite, a tile map like this, to a position based on a specified width and height of that tile map. So that's what we're doing there. So that is how we are instigating that tile map drawing routine that we saw last time. So the important thing that we need to look at now is the do crop routine. Now, if you've seen my simple series, you can actually probably just finish this tutorial now, because it's basically the same as it was before. So basically we have a sprite and we need to do cropping for positions like this. Now the first thing we're actually doing here is we are checking the flag bit and seeing if we are flipping horizontally the sprite. Now the problem is that the drawing system isn't really designed for flipping sprites. It's been kind of kludged on, and for that reason the cropping routine basically will not work correctly with a flipped object, because the drawing would want to start from the right and move to the left, but the cropping routine is designed to work from the left and go to the right. And so to get around the fact that it can't really do it, what we're doing is we are basically flipping the coordinates and running the do crop routine with the coordinates flipped to the opposite side of the screen, and then we're flipping them back. So that's the way we're working around this in this version. Mintile is very crude and wasn't really designed for that kind of crop flipping really. I'm working on a new tile map routine called MinTile, which is more advanced, and it is designed from the ground up with both X and Y flipping of tiles and simulating sprites using those tiles again. So that will give more functionality. But this version, it's very limited. So what we're doing here is we're loading the width of the screen, and we're then subtracting the width of the sprite and the start position of the sprite. And so what we're basically doing is we are flipping the position of our sprite. If our sprite is flipped, we are moving our sprite to the other side of the screen, calculating the crop and then flipping it back. And that is what you can see being done here. And after the crop's been performed, we are flipping it back, considering the screen width here, and moving it back to the opposite position. It's a bit crude, but it pretty much works. And as I say, it allows the same cropping routine to work with the flipping, and the drawing routines will work okay. So how do we do our crop? Well, as I say, it's the same as the simple series. Basically, we've got DE, which are our temporary variables. And what we do is we consider the top and the bottom of the sprite first. So here is our imaginary sprite, and we consider it at the top of the bottom of the screen, and we do any cropping, and then we do left and right after that. So DE is our amounts to remove from the top and the bottom. So first we are taking the Y position of the sprite, and we're subtracting the minimum logical coordinate, which I think is like 64 or 48 or something. And so that will move the value of the Y position up, and that may go negative. And if it goes negative, that means basically we're off the top of the screen. So if we've not gone negative, then we don't need to crop the top of the screen. But if we have, then we are converting that back to a positive, and we are basically rounding it up so that we get an even number of tiles. Now, what we're then doing is we are going to see if basically that is the amount that is off the top of the screen is the entire sprite. If it is, we're going to jump to this all off screen routine here. And the all off screen routine, where is it? All it does is it sets the carry and returns. And so that tells the calling routine by the carry, well, actually, there's nothing to draw. Now, if the sprite is partially off the top of the screen, we're going to need to remove some of the tiles, but we might be only partially off the screen, but we're going to have to remove a whole tile. And so we need to move the draw position down a little bit to basically keep the sprite moving smoothly as entire chunks are taken away. And so to do that, we do an AND of the bottom two bits, and then we flip those bits to calculate the new Y offset for the first tile to draw compared to factor in the missing part of that tile. So that's what we're doing there. We're then storing the new Y position. We're then adding the height of the sprite, and we're now considering if the sprite is off the bottom of the screen. Now, if we've not gone over the entire height of the screen, and then we are not off the bottom of the screen. But if we are, we're converting that to a number of tiles and seeing if that's the entire height. Now, before we stored the amount removed from the top in E, now we're storing the amount removed from the bottom in D, and so we've got those two values now. We are converting that to a number of tiles, and we're adding those together. And if the amount to remove is 0, there's nothing to crop from the top, but otherwise we are subtracting that from the old height and storing the new height here. Now, in the case that our sprite is off the top, we're going to need to skip some of the tiles of the tile map before we start drawing our character. And so that's what we're going to do here. We are taking the amount to remove from the top, we're converting that to a number of bytes, because basically it's 1 tile per byte. This is the number of bytes per line we're calculating here. We're then calculating the number of lines of tiles to remove here, and then we are removing those, basically adding the number of tiles in the lines to skip from IY, which is IY is the tile map source, so the first tile that we need to draw. So we're just skipping them if we're partially off the top of the screen. So that's what we're doing there. So we've now cropped the top and the bottom. We're now going to do the same for the left and the right. So we're resetting our temporary variables there, and we're going to take the X position. We're going to subtract the minimum logical visible X position here. And once again, if we are off the left hand side of the screen like that, we are then going to basically round that up to a number of tiles, compare that to the width of the graphic here. And if we're entirely off the screen, we're going to give up again. Otherwise, we're storing the amount to remove from the left in E. We're converting the X position into an offset here for the to keep the movement smooth there, basically. And then what we're going to do is we're going to add the width of the sprite, and this time we're comparing it considering if it's over here. We are then going to check again and see if we are entirely off the screen there. And if we are, we're going to basically jump here. Otherwise, we are going to store the amount to remove from the right in D. Okay, so we add those two together, convert them to a number of tiles. If the result is 0, then there is nothing to crop. But otherwise, we need to basically alter the width. So that's what we're doing here. We're updating the width in tiles here. And then we are going to, if we are off the left-hand side of the screen, again, we need to skip a couple of tiles at the start of our tile map to compensate for this part here. So that's what we're doing here. We are converting the amount to remove from the left to a number of tiles, adding it to the tile map in IY. And at this point, we're now done. And so when we return, IY points to the tile map to draw with any tiles removed. And the X, Y position and width and height, while still in logical units, are now the correct coordinates for us to draw to the screen and the number of tiles to draw. And so what we will do with those is we will convert the width and height to a tile count, and we will use the X and Y position with the get screen pos routine, which is platform specific code, and will calculate the VRAM destination for our system. It's all a bit complicated, I know, but as I say, this is a good simple tile map. I get a lot of people and they ask about, oh, can you show me how to do tile maps and things like that? And in a simple sense, basically anything that's printing characters to the screen is also almost a tile map. But people, of course, you want a grid routine, but it starts to become quite difficult when it comes to systems like the CPC, which is not fast. Redrawing an entire screen on the CPC takes quite a lot of processing power, and so you have to start getting a little bit tricky. You have to have quite optimized code for drawing the tiles to the screen, and these routines also have optimized code for updating the tile map and not drawing more than needed. And as I say, the examples today also use a single buffer, which also add more complexity. So unfortunately, a simple tile map doesn't end up all that simple, but hopefully this one at least will give you some ideas, and maybe you can use the parts that you find helpful, and you can write better ones or simpler ones depending on your requirements for the bits you don't. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.